oh, this is supposed to be a 2x right here. This is going to be a 2x right there. 2x right here. Sorry about that. It should have been 2x square root of 2x. So you end up with 2 all over square root of 2x plus the square root of 2x, which is equal to 2 all over 2 square root of 2x, which becomes 1 over square root of 2x. That is your derivative function. Like I said, sorry about that. I should have been 2x right there, and so it should have been 2x, 2x, 2x here. And so you end up with 2 over square root of 2x plus square root of 2x, which then cancels with the 2 right here. Noted in orange just to make sure that this becomes 1 and that becomes square root of 2x. So there you go. We just derived the derivative function. We're going to use the power rule, the quotient rule, the product rule, and the chain rule to figure out an easy way to do all of this math later on. Okay? That was the first example. Let's do another example. The second example I'm going to do, shall we do a real simple one? Yeah, let's do a real simple one. Example 2. The function looks something like this. It's a really easy example. X squared. It's quadratic in nature. It's got a degree of 2 located right there. So we're trying to find f prime of x. Before we do that though, always write down f of x plus h. F of x plus h, we plug it into this equation. X plus h in here, you end up with x squared plus 2xh plus h squared. Don't forget that was supposed to be x plus h quantity squared, and that's what it comes out to when you distribute that out. So f prime of x is defined as the limit as h approaches 0 of f of x plus h minus f of x all over h. That becomes x squared plus 2xh plus h squared minus the quantity f of x right there, which was x squared all over h. Notice something magical happens. The x squared and the minus x squared will cancel out. I'm going to rewrite this really nice and neat for you. It's the limit as h approaches 0 of 2xh plus h squared now all over h. Notice that one of these h's, I'm going to use a different color pen this time. Notice one of the h's cancel here, and this becomes just h. That term right there plus h. So the second part of the equation that we end up with becomes 2x plus h. What's the limit as h approaches 0 of this function right here? That approaches 0, you end up with simply just 2x. We could derive the power rule. In fact, there's nothing in the denominator that we have to multiply. But in this case, we could derive the power rule of x squared to get to 2x a little bit later on, and I'll show you the easy method later. So let's do another problem, number 2. The function looks something like this, example 3. F of x is equal to 1 over 1 plus x, and we're trying to find f prime of x. We notice that f of x plus h is equal to 1 over x plus h plus 1. So we just plug in x plus h into that x and replace it. You end up with x plus h plus 1, 1 plus x, same thing, 1 plus x plus h, or x plus h plus 1. Anyways, by the definition, the limit as h approaches 0 is defined as, is of f of x plus h minus f of x all over h. That's what we're trying to find. You plug in the information here, you get 1 over x plus h plus 1 minus 1 over x plus 1, same thing, 1 plus x, all over h, and the limit as h approaches 0 for that function. Notice that we don't have a common denominator, so we have to make a common denominator. The easiest way to bust this fraction, that's I coined it myself. Some teachers, most teachers, 99% of teachers will call it fraction busters. I'm going to call it bust that fraction. So I'm going to bust that fraction from a complex one into a real simple one. Well, the common denominator is x plus h plus 1 times x plus 1. So x plus h plus 1 times x plus 1 in the numerator, x plus h plus 1 times x plus 1 in the denominator. So we'll multiply the top and the denominator and the bottom by the LCD, or the least common denominator. So if you multiply this to the first term, the x plus 1s will cancel because this is in the denominator, this is in the numerator. So you end up with just x plus 1 in the numerator. Again, I'm going to reiterate this. If I take this factor and multiply it, I'm going to distribute it. The x plus h plus 1s will cancel because this is in the numerator, this is in the denominator. You're going to end up with just x plus 1. Minus now the quantity. Notice that the x plus, when we multiply this factor to this term right here, we're going to end up with canceling the x plus 1s because this is in the numerator, this is in the denominator. So you're going to end up with minus x plus h plus 1 all over. And then, like I said before, I'm going to always keep it factored. H times x plus h plus 1 times x plus 1. Like I said before, there's something magical that's going to happen. The x's will always cancel. X minus x plus 1, and then minus 1 is always going to cancel. You end up with just minus h in the numerator. Now, what do we do? Oh, like I said before, the h's will cancel. You end up with negative 1 in the numerator, and this is just 1. So let's rewrite it really neatly. What's the limit as h approaches 0 of negative 1 all over x plus h plus 1 all over x plus 1. And what's going to happen? I'm going to use, let's use purple this time. The h approaches 0. That's 0. So end up with x plus 1 over x plus 1. And so my final answer is going to be negative 1 over x plus 1 quantity squared. That we just derived the derivative function, or the tangential slope function. Again, it's very, very important you understand this. This is the tangential slope function, or f prime of x. Okay, that should help you get started with the derivative when it is the definition using the limit process. This was actually the best thing that ever happened in calculus or math in the 16th, 17th century. This is just phenomenal stuff. If this wasn't discovered by Sir Isaac Newton, we wouldn't be here today, because every type of electronic device, everything that we do is derived from these math equations. Good luck on your homework, and if you have any questions, let me know. Thanks. Bye.